Hello, welcome back. This is Nagarajan, working as an assistant professor in MAM School of Engineering, Trichy. So, in the previous classes, we are discussing about the different techniques of blood cell count. Okay, so now we are going to discuss about one of the blood cell counting method, that is laser based, and another one is auto, that is Coulter method, conductivity method, that is Coulter method. Okay, fine. Let us go into the topic. So laser beam. Okay, so laser based method. So this is one of the modern technique that is used to determine the number of RBCs, WBCs, and platelets. Okay, so how it is measured? Okay, then here the principle behind this laser based counting is the angle of scattering, the angle of scattering of light. Why the angle of scattering of light is taken into account? Because RBC will have the definite size, definite shape. Okay, whereas this WBC is also can be accounted, but it is not it is in definite size, but it is not in a definite shape. Whereas platelet is also it is having it is small in size compared to RBC and WBC, whereas it is also having a definite shape. So here, when the light rays incident on these objects, okay, these cells, RBC or WBC or platelets, the light will get scattered. Okay, that scattering light is taken into account for the counting of these cells. Okay, and here there are the scattering of angle of platelets and RBCs are counted because WBC does not have any definite shape. Okay, whereas RBC and platelets will have a proper shape. Therefore, that will deflect the laser light in an angle. Okay, in a particular angle. Okay, so there are two detectors are utilized. Okay, two detectors. One is to detect the RBC and another one is to detect the platelets. Okay, so photo detectors. Then this output from the photo detector is given to the digital voltmeter to count the number of cells. To count the number of cells. Okay, then lysing agent is used to destroy the RBC. Okay, if RBC is destroyed, then what will happen? The WBC will remain. Then we will go for measuring the WBC count, because if RBC is destroyed, then WBC by default platelet is we are already counted. And next, if you do the same solution second iteration, we will be getting the WBC count. Okay, so this is the method of counting the laser based counting. So here laser source. Okay, this is the laser source, and this is the blood sample we are allowing, and there are two detectors. Okay, laser light is falling on the blood cell, and that is deflected to detector 1 and detector 2. Okay, detector 1 will be for RBC and detector 2 will be for platelets. Okay, so these detectors will count the number of light incident on it, and finally it will send the digital output to the signal conditioner, and finally it will give the number of counts it received. Okay, incident light incident on it, and finally it will give the total number of counts. Okay, so next. Next, we are going to discuss about the conductivity method or Coulter method. Okay, so conductivity method. What does it mean? Conductivity. Okay, electrical students will be knowing what is meant by conduction. Okay, what is meant by open circuit and what is meant by short circuit. Okay, so short circuit is type of conduction. Open, that is, it is sorry, not short circuit cannot be discussed here. When the switch is on, the power current flow takes place, and when the switch is off, the current flow stops. Okay, so on, current flow starts, off, current flow off. Okay, so here we can see on and off, on, off, on, off. Okay, so number of times it is made on and number of times it is made off. Okay, so continuous conduction, and when we are switching off, it is taken into 1, and again it starts conducting, and again it is when it is turned off, it is taken account into 2. Okay, so number of times it is turned off can be counted here. That is why it is called as Coulter method. Okay, so here there will be an arrangement, okay, for the current flow through the apparatus. Okay, through the apparatus with a small hole. The size of the hole will be very minute, so that only the WBC or only the RBC or only the platelets can pass through it. Okay, only the platelets can pass through it. So that very much small amount, very small sized hole. Okay, that hole, it when there is no passage of these cells, then electrical conductivity takes place through that hole. And if any object passes through that, if any cells passes through that hole, it stops the conduction. Very important point. So whatever I said is related to this, but this is the actual point. Okay, there will be a very small hole. When the object passes through the hole, that is, blood cell passes through the hole, the conduction stops. And when the object passes the hole, the conduction starts. And again, when any object crosses the hole, conduction stops. And when it crosses the hole, the conduction on. Okay, so this is the method. Okay, let me show the apparatus in the next slide so that we can understand clearly. Okay, here you can see this. Okay, these are the 2 electrodes, and that electrode is given supply from the source, that is DC source, and there is a small hole. Okay, so there will be an threshold pressure over here. Threshold pressure in the sense it is smaller, similar to the suction pressure. There will be a small hole here. Okay, this is a small hole. Okay, so here when due to this pressure, the liquid will be allowed. The liquid will be allowed through this test tube through a small hole. Whenever any blood cell passes through the hole, the conduction between 2 electrodes stops. Okay, later it starts on, and again when another cell passes, it stops the conduction. Okay, so I will show you a small video related to this so that you can able to understand clearly. Okay, just a moment. So this is the electrolytes. Okay, the aperture tube. So there are 2 electrodes, okay, anode and cathode, and there is an aperture. So these are the molecules, white colored are the molecules. So when it stops conduction. So here is an animation of another method, digital method of measuring the blood cells, that is animated Coulter method. It is an animated method. So if you look at this video, you can able to understand clearly how to determine the RBC, WBC and platelets. Okay, let us have the video. Here this is the blood sample is taken, okay, and in this method we cannot determine manually, so the automatic method is chosen for the blood cells to, that is blood quantity. So here is the structure where the blood is delivered to the counting instrument. Okay, so here is an, as I said, this is a small hole. It's a small hole like structure where only these objects can pass. So whenever the white is passing, it stops conduction. Okay, so through that, based on the light intensity, we can measure all the materials, platelets, RBC, WBC, everything. So this is the count of platelets. Okay, and again here we can find the RBC count. Okay, this is the RBC count. And this is the RBC in detailed, okay, how to find out the condition, health condition of the RBC. Okay, whether the cell is affected with some disease or whether the cell is good, how many dead cells are there, everything we can do this with this analysis. Okay, and leukemia cells can also be detected. Hope hope you understand this presentation very well, that is a blood cell counter, and we will see the remaining topics in the next class. Thank you.